Have you ever wondered what the most extreme events in the universe are? Well, prepare yourself for an interstellar journey that will take us to the most violent and energetic corners of the cosmos. Our universe, in its vast and infinite expanse, is home to phenomena that push the boundaries of human comprehension. We will embark on a countdown, experiencing the 10 most extreme events known to humanity. From the cataclysmic birth of new stars to the destructive force of black holes, we will unravel the mysteries behind these cosmic spectacles. Each event will not only astound you with its sheer power and scale, but also shed light on the fundamental processes that shape our universe. These cosmic events, while extraordinary and violent, provide us with invaluable insights into the workings of the cosmos. They are the universe's own way of teaching us about its origins, its evolution, and its eventual fate. Now let's dive into the countdown with the 10th most extreme event in the universe. Starting off our list at number 10, we have supernovae. Now, what exactly are supernovae? Well, a supernova is a powerful and luminous stellar explosion. This transient astronomical event occurs during the last stages of a massive star's life, whose dramatic and catastrophic destruction is marked by one final, titanic explosion. This explosion is so bright that it can outshine the light from an entire galaxy. But how does a supernova occur? It all starts when there's a change in the core or heart of the star. This change can happen in two different ways, with both resulting in a supernova. The first type of supernova happens in binary star systems. Binary stars are two stars that orbit the same point. One of the stars, a carbon-oxygen white dwarf, steals matter from its companion star. Eventually, the white dwarf accumulates too much matter, causing the star to explode, resulting in a supernova. The second type of supernova occurs at the end of a single star's lifetime. As the star runs out of nuclear fuel, some of its mass flows into its core. Eventually, the core is so heavy that it can't stand its own gravitational force. The core collapses, which results in the giant explosion of a supernova. The supernova explosion not only shines with the brilliance of 10 billion suns, but also releases elements and debris out into space. Many of the elements we find here on Earth are made in the core of stars. These elements travel on to form new stars, planets, and everything else in the universe. So that's the incredible power of supernovae. But hold tight, because we're just getting started. At number 9, we encounter the dense and powerful neutron stars. Born from the explosive death throes of massive stars, neutron stars are one of the most extreme objects in the universe. When a star, significantly larger than our Sun, exhausts its nuclear fuel, it collapses under its own immense gravity, triggering a supernova. What remains is a core so dense that one teaspoonful would weigh as much as Mount Everest, the highest peak on Earth. Neutron stars are not just incredibly dense, they also have an intense gravitational pull. It's so strong that anything straying too close, even light, can be sucked in, never to escape. Imagine a celestial body around 20 kilometers in diameter, but with a mass up to 2 times that of our Sun. It's like cramming a herd of 50 million elephants into a thimble. But don't let their small size fool you. Neutron stars are powerhouses, spinning at incredible speeds and radiating energy across the electromagnetic spectrum. Some even blast out beams of radiation, much like a lighthouse, and these we call pulsars. In spite of their hostility, these remnants of supernova are key to understanding the life cycles of stars and the nature of matter under extreme conditions. They are cosmic laboratories, providing clues to the fundamental laws of physics. As we can see, neutron stars are truly extraordinary, but there's more to come in our cosmic journey. Next up, at number 8, we have the spectacular gamma-ray bursts. Imagine the most powerful explosion that's ever happened in the universe. That's a gamma-ray burst for you. These cosmic firecrackers are the brightest electromagnetic events known to occur in the universe, so bright that for a few brief moments they outshine everything else in their vicinity. So, what's the cause of these spectacular displays? Gamma-ray bursts are believed to be the product of supermassive stars collapsing in on themselves, or the result of neutron stars merging together. Either way, the resulting explosion is so powerful that it punches a hole through the star, sending a jet of gamma rays shooting out into space. Now, let's talk numbers. A single gamma ray burst releases more energy in a few seconds than our sun will over its entire 10 billion year lifetime. That's an astronomical amount of energy. But what would happen if a gamma-ray burst occurred near Earth? The effects could be catastrophic. If the burst was close enough, the intense radiation could strip away the Earth's ozone layer, exposing our planet to harmful ultraviolet rays from the sun. This could lead to mass extinctions and drastically change life as we know it. Thankfully, gamma-ray bursts are extremely rare, and the chances of one happening near Earth are incredibly slim. But they serve as a powerful reminder of the immense energy and destructive potential that exists out in the cosmos. Gamma-ray bursts, truly one of the universe's most dangerous fireworks. At number 7, we delve into the mysterious world of black holes. Imagine the densest object in the universe, so dense that nothing can escape its gravitational pull, not even light. That's a black hole for you. Born from the death throes of massive stars, these cosmic beasts are nothing short of awe-inspiring. When a giant star collapses under its own weight, it forms a singularity, a point in space where gravity is so strong, it forms a black hole. But what's so special about black holes, you ask? Well, they're not just any ordinary celestial object. They warp space and time around them, a phenomenon we call gravitational lensing. It's like a celestial magician bending the fabric of reality. Now, imagine being near a black hole. It's a cosmic rollercoaster ride you wouldn't want to be on. As you approach the black hole, its gravity pulls stronger on your feet than your head, stretching you out like a piece of spaghetti. This process, charmingly known as spaghettification, is just one of the many extreme effects of a black hole. And yet, despite their destructive nature, black holes play a crucial role in our universe. They help in the formation of galaxies and influence the path of stars. They are, in a way, cosmic architects shaping the universe. Black holes, the universe's ultimate devourer. But our cosmic journey doesn't stop here. Number 6 on our list takes us to the rapidly spinning world of pulsars. A pulsar is a highly magnetized, rotating neutron star that emits beams of electromagnetic radiation. These celestial objects are birthed from the spectacular demise of massive stars in supernova explosions. The core of the star collapses under its own gravity, and the outer layers are blasted into space. What's left is a super-dense spinning neutron star, or a pulsar. These cosmic powerhouses are unique in several ways. For starters, they're incredibly dense. A sugar cube-sized amount of pulsar material would weigh about 1 billion tons on Earth, roughly the same as an entire mountain. Pulsars also spin at an astonishing rate. Some rotate hundreds of times per second, faster than the blades of a domestic blender. And they're precise. The regularity of a pulsar's pulses is comparable to the accuracy of an atomic clock, making them invaluable for testing the laws of physics. The most distinctive feature of pulsars, however, is the lighthouse-like beams of radiation they emit. These beams sweep across the universe like a cosmic spotlight, observed from Earth as a periodic pulse of light. So, there you have it, a quick tour of the mesmerizing world of pulsars. These spinning neutron stars are not only some of the densest objects in the universe, but also some of the most accurate timekeepers known to science. Pulsars, the cosmic lighthouses, but get ready because we're entering the top 5. At number 5, we have the brilliantly bright quasars. Quasars, short for quasi-stellar objects, are the most luminous entities in the universe, outshining entire galaxies with their intense light. Imagine a celestial lighthouse radiating its beacon across the vast cosmic sea. That's a quasar for you. These cosmic juggernauts are powered by supermassive black holes at the hearts of distant galaxies. As material spirals into these black holes, it heats up and emits enormous amounts of energy. This energy emission, incredibly, can be 1,000 times brighter than the entire galaxy that houses it. The brilliance of quasars is not their only remarkable feature. They also play a pivotal role in shaping the galaxies they inhabit. The energy and radiation they emit can trigger star formation or halt it entirely, sculpting galaxies into the diverse shapes we observe today. In fact, studying quasars offers us a tantalizing glimpse into the distant past. These celestial beacons are so far away that their light takes billions of years to reach us. Therefore, observing a quasar is like looking back in time, offering us insights into the early universe. Quasars are not just lighthouses in the cosmic darkness. They are time machines, they are galaxy shapers, they are energy behemoths. They are truly one of the most extreme and fascinating phenomena in our universe. Quasars, a beacon from the early universe, but there's still more to explore. Number 4 brings us to the universe's most powerful magnets, Magnetars. These are not your everyday refrigerator magnets, but celestial bodies with magnetic fields 1,000,000 billion times stronger than Earth's. Imagine a magnet so strong that it could strip the information of a credit card from halfway to the moon. Now, how do these magnetic monsters come to be? They're born from the explosive deaths of massive stars, supernovae, leaving behind a core of neutrons so dense that a teaspoon of it would weigh as much as a mountain. In some rare cases, these neutron stars spin incredibly fast and have exceptionally strong magnetic fields, becoming magnetars. The magnetic field of a magnetar is so intense that it warps the very fabric of space around it. This extreme magnetic field can cause starquakes, which are similar to earthquakes but occur on the surface of the star. These starquakes release a gargantuan amount of energy, leading to intense bursts of radiation that can be detected from across the galaxy. But it's not all doom and gloom. Magnetars are fascinating objects that push the boundaries of what we know about physics, providing invaluable insights into the exotic states of matter and the extreme conditions of the universe. Magnetars, the universe's magnetic monsters, but brace yourself for the top 3. Coming in at number 3 are the colossal galactic collisions. These are not just celestial fender benders, but grand cosmic ballets performed over eons and on a scale that dwarfs our human comprehension. Imagine, if you will, 2 galaxies, each comprising billions of stars, gas, dust, and dark matter, spiraling towards one another, drawn by the irresistible pull of gravity. Yet, despite the countless components, actual star-on-star collisions are rare thanks to the vast distances between individual stars. Instead, the galaxies meld and twist, their structures warping under the gravitational tugs of war. The timescale for these galactic collisions is staggering. We're talking hundreds of millions to even billions of years. This is a process that unfolds at a pace far slower than the blink of an eye, yet the effects are no less dramatic. When galaxies collide, they don't merely bounce off each other or shatter into cosmic rubble. Instead, they merge, their stars and gas intermingling to create a new, larger galaxy. Sometimes this results in an elliptical galaxy, a vast spherical collection of stars. Other times it might create a peculiar galaxy, one with a unique shape defined by the specifics of its collision. Galactic collisions, a cosmic dance on a grand scale, but we're not done yet. There's still more cosmic spectacles to come in our countdown of the most extreme events in the universe. At number 2, we have the event that started it all, the Big Bang. The Big Bang is not just a theory, it's the most widely accepted explanation for the origin of the universe. Imagine everything we see, the countless galaxies, stars, planets, all the matter and energy, everything contained in a single, infinitesimally small, infinitely hot and dense point. And then, in an instant, a cataclysmic explosion, a bang, if you will, of such enormous scale that it gave birth to time and space themselves. For a moment, let's delve into the evidence supporting this monumental theory. The first piece of evidence is the universe's expansion. In the early 20th century, Edwin Hubble observed that galaxies are moving away from us in all directions. This led to the conclusion that the universe is expanding, suggesting that it started from a single point. The second piece of evidence is the cosmic microwave background radiation, or CMBR for short. This faint radiation left over from the Big Bang fills the universe and can be detected from every direction. It's a snapshot of the universe about 380,000 years after the Big Bang, when the cosmos cooled enough for light to shine through. The third piece of evidence is the abundance of light elements. The Big Bang theory accurately predicts the percentage of hydrogen, helium, and other light elements present in the universe. So, what does the Big Bang imply for the origin of the universe? Well, it suggests that the universe was once in an extremely hot and dense state. As it expanded, it cooled, and structures like galaxies began to form. It's a model that beautifully explains the current state of the universe and its evolution from a simple, hot and dense early state to the complex structure we observe today. The Big Bang, the birth of our universe, but prepare yourself for the most extreme event. And finally, at number 1, we have the ultimate end, the heat death of the universe. The heat death of the universe is a concept that might sound like something out of a science fiction novel, but it's a very real and sobering prediction within the realm of astrophysics. It's tied inextricably to the second law of thermodynamics, the rule that governs the flow of energy in our universe. To understand the heat death, we first need to grasp the essence of the second law of thermodynamics. This law dictates that energy in a closed system will always move from a state of order to disorder. It's like a deck of cards. If you throw them in the air, they're far more likely to land in a jumbled mess than in a neatly ordered stack. The universe, in a grand cosmic sense, is no different. Now, let's apply this to the universe. Stars, galaxies, black holes, they're all pockets of order, high-energy systems. Over time, the second law dictates that this energy will spread out, becoming more and more disordered. Eventually, there will be no more stars burning brightly, no more galaxies spinning. Instead, the energy will be evenly distributed across the universe in a low, uniform temperature. This is the heat death. But what does this mean for the future of the universe? Well, it's a bit of a downer. In a universe that has reached heat death, there is no more energy to fuel new stars or galaxies. Everything becomes static, unchanging. It's a universe devoid of the dynamic, energetic processes that make it so fascinating today. However, don't start panicking just yet. The heat death is still a long, long way off. We're talking timescales so vast they dwarf the current age of the universe. And who knows, maybe by then we'll have figured out a way to reorder our deck of cosmic cards. The heat death, the universe's inevitable fate. That concludes our journey through the 10 most extreme events in the universe. So, there you have it, the 10 most extreme events in the universe. From the cataclysmic eruptions of supernovae, shedding light on the life and death of stars, to the enigmatic neutron stars, the densest objects in the universe. We've delved into the mystery of gamma-ray bursts, the most powerful explosions known to man, and explored the abyss of black holes, where time and space warp and twist. We've marveled at the pulsars, cosmic lighthouses guiding us through the universe, and the quasars, which illuminate galaxies billions of light years away. We've faced the raw power of magnetars with magnetic fields trillions of times stronger than Earth's. We've witnessed the beautiful chaos of galactic collisions and pondered the birth and inevitable heat death of our universe. Remember, the universe is full of wonders and extremes, each more fascinating than the last. So, keep exploring, keep wondering, and until next time, stay curious. As we prepare to dock our spaceship from this cosmic journey, we'd like to express our gratitude towards you, our fellow astronauts of the universe. Your support fuels our mission of bringing the celestial wonders to your screens. If you've learned something new from this voyage, we would appreciate if you could hit that like button and share your enlightenment in the comments below. We are curious to know your favorite cosmic occurrence. Is there a celestial topic you'd like us to delve into in a future video? Your insights guide our interstellar excursions. Do share this video with friends and family who might share your curiosity for the divine secrets of the universe. If you're not a subscriber yet, consider subscribing and don't forget to hit the notification bell to ensure you never miss our future explorations. Remember, the universe is infinite and there's always a fresh finding waiting. Hence, let's persist our journey together, exploring, contemplating, and understanding the magnificent cosmos we inhabit. Until our next expedition, stay inquisitive and keep aspiring for the stars.